on this one here. Yes. So this is the things where we finished last time here. We are doing the composite Simpson rule, and in the composite Simpson rule, we did the example. If you remember, this is the last example we did for 5.31 here. And let's do the next example. Before that one, I give you the error term and the error bond formula for the composite rule. This is the error term, b minus a taken by 180 h4 and 4 derivative of the function at eta. Eta is a known point in the interval. If we don't want to involve eta, we use the error bond formula of the composite. And this is the error bond formula of the composite is what? Is h power 4 b minus a taken by 1/80 into m. And what is m? The maximum value of the 4 derivative of the function inside the interval. Let's take the very simple example. And he say, approximate this integral with an error less than 10 minus 3 using the composite. Yeah, this is a very good example here. He say approximate this integral. When we approximate this integral with the help of the composite rule, what we need, please? We need at least one condition. Either teacher give you h, or he give you n, or he give you number of points. But in this example, we don't have any of them here. So, but he give you the condition that the error is less than 10 minus 3. So he give you the accuracy. So it's mean first you have to find out h or n. And then when you have the h, you can easily find out the number of point, because your initial point is 0, final point is 1. And between how many points we have? This is only we can know if we know the h here. So first thing he say, find the approximate this integral with error less than this one. So this is the formula given. It is given less than or equal to 10 minus 3. So we need what? B. B is given 1. We need A given 0. M we can easily find out because we know the function e minus x. We can find the 4 derivative and then find the maximum between 0 and 1. Only things we don't know is h, and we can easily find out the h here. When we have h, then we can have to find the approximation. So this is the things we are given. We are given f of x is equal to e minus n, and we can find out the 4 derivative, inshallah. The 4 derivative of this function is this one. And then you find out the maximum value of the 4 derivative of the function inside the interval. And when you find the maximum value of the 4 derivative of the function and 4 derivative of the function, your function is what? 16x4 minus 48x squared plus 12 taken by e power x squared, because it is e minus x squared. So you can take in the denominator. Maximum points you will find at 0. And at 0, what is you have? Denominator is 1. So your 12 by 1, which is 1. So this is your maximum value. So you know everything now. You know B, you know A, you know M. H you can easily find, or take all the term on the right hand side and simplify. And when you simplify H or N by using this one, I just find N, and N is equal to 2.86, because I convert your H into the form of N. We know what is H. H always equal to B minus A taken by N. What is your B? 1. What is your A? 0. So 1 minus 0 taken by N. So 1 by N power 4. So this is same thing. So either you use find H or you find N, same thing. I find N and 4, you will get this one. Take the 2 times square root or the 4th root of the right hand side. You get 2.84. It means N is this. So since we are talking about Simpson rule, we cannot take, because next integer we take 3, but in Simpson rule we cannot take 3, because Simpson rule requirement is always even. N must be even in the Simpson. So it means what is your N? So when N is your N, you can easily find out H. H formula is what? It is a B minus A taqseem by N, which is 1 by 4 is a 0.25. Now, you know the 0.25, so you can easily find out the first point. The first point is a 0, the last point is 1, and the middle points we have is what? The middle points we have with the same H here. Your X naught is given 0. Your X1 is equal to 0 plus H. 0 plus H is what? H is your 1 by 4, means a 0.25. It is a 2, 5. What is your X2? X2 is 0.25 plus 0.25, which is what? 0.5. X3 equal to what? 0.75. And X4 is equal to what? The 1. And now we know what is the value of the, what is the formula say? H by 3, 1 by 4 by 3. Value of the function at the first point and the last point should be multiplied by 1. Yes, it is. And the middle one, all the odd point are how many odd point we have? X1 and X3. Odd point should be multiplied by 4. And even point, we have only one. X2 is multiplied by 2. And that's the formula we can have here now. Now you know your function is e minus x square, f of 0 equal to 1. And you can easily find out what is f of 1 by 4. Put x place 1 by 4. And when you simplify, inshallah, you will get this approximation. And that's the things you can have here now. Approximation. This integral with the help of composite rule is 0.74 here. And I told you that the here not H given, not N given, not number of point given. So it's mean first we use the error bound formula and calculate either H or N, and then we can use composite rule. Okay. This is simple example, and this example he give you the table, so we can easily use here. Now he say find the approximation of this integral from 0 to 1.2 f of dx taking h is equal to 0.3. We are given many points, but we have to select such point with the distance between them should be 0.3. So we have to choose what? 0, 0.3, 0.6, 0.9, and 1 point. This one. So you have how many points? You have a 5 point, mean n is equal to 4. Yes, we can use Simpson rule. And Simpson rule is what? H by 3. And Simpson rule for 5 point or n is equal to 4 is what? This is your x naught, this is x1, this is x2, this is x3, this is x4. So value of the function at the first point and value of the function last point should be multiplied by 1. And middle point, odd function, odd point function value is what? F of x1 and f of x3 multiplied by 4, and odd point on even point only 1. So which is multiplied by 2 here. So you put the value here. What is f of x naught? F of x naught is 1. F of x1 is what? 1.26 plus f of x3 is a 1.52, and f of x2 is what? 1.43 multiplied by 2, and f of 1.2 is 1.56, and you can have this. What is the second part? He said the table for this one is given f of x is equal to x cosine x. Now he said compute the error bound and the absolute error. Yes, absolute error teacher can ask you in this here, because the absolute error for this problem is very simple, because exact we can easily find out. So how can you do this one? First, we need the error bound formula. Error bound formula need 4 derivative of the function. So we have given f of x is equal to x plus cosine x. First derivative is 1 minus sine x. Second derivative is minus cosine. Third derivative is sine, and fourth derivative is the cosine. And we need the maximum value of the 4 derivative inside the interval. Your interval is what? 0 to 1.2. Your what you call your b is 1.2, your a is a 0 here. Then you can use is h 0.3, h power 4, b minus a 1.2 minus 0 is 1.2, taqseem by divided by 180. into maximum value of the 4 derivative, and we just calculated m is a 1. So that's what we have here. And the third part is what? And the third part, now the second part we are doing, and he's also find the absolute error. Absolute error, we need exact. An exact integral for a given function is what? We know what is the antiderivative of x. It is x squared by 2. What is the antiderivative of cosine? Is a sine x. And then you calculate at 1.2 and 0. And of course, you will get 1.6520. This is your exact. Approximate, we just find approximate 1.6521. So this is the difference between them. This is the absolute error we have. What is the third part? The third part, same, how many subinterval approximate the given integral within the accuracy 10 minus 6. And for this, we have to use this formula. This is a error bound formula in the sense of n. So I convert h into, because in the error for formula we have h, but I convert h into n by using this condition. H always equal to b minus a over 4. So by using this formula, we are know m is 1. So we only calculate n4. When you find n4, take the square root 2 times, you can have the value of n. And after simplify, inshallah, you will get n is greater than or equal to 10.8432. It means we cannot take the next integer because next integer is 11, but we cannot take 11 in Simpson rule because Simpson rule say and must be even. So it means we have to jump it and we have to take very after that integer, which is 12. And when we have a 12 subinterval always mean we have a 13 points here. So this is a very good example from examination point of view. Let's take one more example. Same like this one here. Here the table given here, the function directly given here. So you say consider the integral, find the approximation with the help of composite. But I told you, please, in exam, teacher never give you the Simpson rule and trapezoidal rule. In exam, teacher generally say use the best integration rule. And best integration rule, when teacher say, it means you have to calculate, and teacher will never give you n. Either he give you number of points or he give you h. So when h is given, you can easily find out n because we have the formula b minus a over h is equal to n. If your n is even, always use the Simpson rule because Simpson rule, as I told you, is one of the best integration rule. But the problem with the Simpson rule is what? Should be even subinterval. But if n is odd, of course, you cannot use Simpson rule. You have only one choice to use the trapezoidal rule. So if I give this problem in the exam, I say consider the integral and number of points are 7. Then I say use the best integration rule. Number of points 7 mean n is equal to 6. It means the best rule is a Simpson rule. And then your n is given 6. You can easily find out h because h give you the number of points. So h is what? B is 2 minus a is 1 taxim by n, which is 6. So h 2 minus 1 over 6, which means h is equal to 1 over 6. So you can easily find out the number of the point. X naught is equal to 1, x is equal to 2, and the middle point you can find with the help of this spacing 1 over 6. So you have x1 is 7 by 6, x2 is 8 by 6, x3 is 9 by 6, x4 is 10 by 6, x5 is 11 by 6, and x6 is equal to 12 by 6, which means 2. Now, use the formula h by 3, value of the function at the odd point multiplied by 4. How many odd points we have? x1, x3, and x5. Value of the function at these points should be multiplied by 4. How many odd point, even point we have? x2 and x1, 2 only. We multiply by the function value at the even point by 2, which is I did here. This is the corner point, end point. Value of the function at the first and the last should be multiplied by 1. And the middle odd function value should be multiplied by 4. So we have x1, x3, and x5 plus 1 because given ln x plus 1. And how many odd point we have? X2 and x4. And then we use calculator and you can have the simply value is 0.909. The 5 we have. We finished the first part. What is the second part? He said compute the error bound for the approximation of this one. Error bound, we need the 4 derivative of the function. Your function is a very simple one. Your function is ln x plus 1. What is the first derivative? 1 over x plus 1. What is the second derivative? Minus 1 over x plus 1 square. What is the third derivative? Is 2 over x plus 1 power 3. And what is the fourth derivative? Minus 6, the same, y divided by x plus 1 power 4, which I give here now. And you find the maximum value of the 4 derivative inside the interval. Interval is 1 and this. And the 4 derivative maximum value is 0.376. Now, use the formula h square, which is h is 1 by 6, 4. I didn't write here b minus a because we know b minus a is what? 1. 2 minus 1 is 1. So no need to write here 1 by 80 into m. M we just calculate here and then we can find the error. A very good error. Should be very good because we are dealing with the Simpson, and Simpson always the best in numerical integration rule. Third part, I say find the absolute error. Now here we cannot find the absolute error because your function is difficult, because here we have to use integration by parts, which is the complete problem. So if your function is a very simple, then teacher can ask you the absolute error, otherwise no need. The last part, he say how many subintervals? Same thing like we did before. How many subinterval with the accuracy 10 minus 4? And we know this is your error formula in the sense of n. The error bound formula for the composite rule. So we have b is 2, a is your 1, and m we just find out is 0.375. You put the value there, take n power 4 on the right hand side, 10 minus 4 on this, and simplify, and you will get n is greater than or equal to 2 point something. It means we have to take very next integer, which is 3, which we cannot take in the Simpson. So we have n is equal to 4. It's 4 subinterval. Need one more example. This is the same thing we can have here now. Sometime teacher give you this example also. Such type of example we solve with the help of the trapezoidal. So same, determine the number of subinterval with an error less than 10 minus 6 and using composite rule. And after you have n, then he say approximate this integral, because when you have n, you can easily find h, the middle point, and then you can use the formula. So your error bound formula is b minus a 1 over 80 h power 4 m. You know m, you can easily find m because your function is given. This, you can need the 4 derivative of the function. The 4 derivative of the function is 24 over x plus 4. And then you find the maximum value of the derivative inside the interval from 0 to 2. And the maximum value inside the interval, you will find out 3 over 28. So m is 3 over 28, 128. Then you put the value here. You can calculate h. H is equal to 0.7872. And you can calculate n by using this one, because question given is number of subintervals. So you have 2.5. N must be even, so we have to take n must be greater or equal to 4 to get this accuracy. So when n is equal to 4, h is equal to 0.5, and now you can have the middle point easily with the spacing is 0.5. So you have first point is 0, second point is what? is a 0.5. Third point is what? Is a 1. Fourth point is what? 1.5. And the fifth point is 2. Odd point multiply by 4. And even point function value multiply by 2. And you use the formula, composite Simpson rule. Inshallah, you will get this 1.055. What is next? Let's call this is the last example we have here now. No, this is now because this example, no need for doing this one here, because here this example slightly difficult here, because this example he say use the best integration rule to compute the integral. You can see we need we must take the first point and we must take the last point, right? And the point should be the equal space. So how can we take this one here? It is, we have to decompose into 2 parts. And the 2 part is what? 0.051 should be equal to 0.052 plus 0.221 here. So this is, this is the equal space. And what is the difference? Is a 0.5, right? And this is from 0.5 to point. How many points we have? 1, 2, 3, 4. 4 point mean n is equal to 3. And n is equal to 3. We cannot use a Simpson rule. We can only use the trapezoidal rule. And from 0.2 to 1, you have equal space. 1.1. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 point mean n is equal to 8. And n is equal to 8 mean the Simpson rule. So you convert this given integral in 2 parts. In the first part, you apply what? You apply composite trapezoidal rule, because here in this part we cannot use the Simpson, and the second part we can use the Simpson rule. And for first, when we use composite trapezoidal rule, we have this approximate, and when we use this integral for the Simpson rule, we have this one. So this answer plus this answer will give you the maximum value of this is the things we have here, please, for the case of it. And this, we finish chapter number 5. You have any question, please? And this is the material for your final exam, because we will not do the chapter number 6 this semester, because I think one of the teacher has some problem. He cannot finish the chapter number 6. So therefore, why I give my student chapter number 6. So your material for the final exam, the syllabus for 254 this semester is what? Chapter 2, chapter 3, chapter 4, and chapter 5 only. So last topic of your syllabus is numerical integration. Chapter number 6, I give you in the syllabus, chapter number 6, but chapter number 6 will not come in the exam here. Okay, so you clear, please, this one. Now, if you have any question,